All right. Thank you so much for the introduction. I'm not going to waste time in our introduction. All right. You want to take it?
Yeah, so who we are, a little bit about us. Strauss Friedberg is a leading provider of cybersecurity and DFIR services. We've been named a leader by Forrester in both 2022 as well as 2024. We've recently been acquired by Level Blue to be essentially providing the largest pure play cybersecurity MSSP within more or less the world. Today, we'll be talking about how we can enhance our investigations. As we know, we typically start off our total incident response lifecycle with gathering forensic artifacts, followed by looking at them and then going back and gathering more, especially in kind of larger environments. The idea behind Lambda and LMDA, what we're talking about, is to help and simplify the initial gathering phase and kind of help you jump straight into your IR investigations. The idea is you gather as much as you can, at least the critical triage data sets that you typically use very early on in your stages, and how you can use that data set and work through it in a normalized output. I don't know about you folks, but usually when I'm looking through a bunch of different artifacts, I take a lot of time trying to normalize that into my master timeline. So now this way I can work with one simple output or kind of individually all in one normalized format. Lastly, we'll be going through some examples of how we can use visualizations to help our analysis, as well as how we can go through it from a reporting requirement standpoint to our stakeholders. Now about you folks, that's me, when I can enhance my analysis. The agenda, as we already kind of talked about, we'll be going through an overview of LMDA or Lambda. We'll be talking about some forensic artifacts, what we do consider as part of our initial triage pull. We'll be going through some of the finer definitions and how it's implemented. For those of you that don't use Velociraptor very frequently, don't understand VQL, don't worry. We're not going to be diving really too deep into that. And then lastly, providing some examples how I can use this data set from visualization or reporting standpoint. Now, for those of you that don't know what Velociraptor is, but are fans of Jurassic Park, unfortunately this might not be the best place for you. Velociraptor is a tool that is open source. It's currently supported by Rapid7. It was built by DFIR practitioners, meant for DFIR at scale across environments. And it really does make the overall acquisition and analysis process a lot faster, especially in larger environments.
All right. Thanks, Kostya. So now that we know what we're going to talk about, let's dive a little bit in depth of what Lambda actually is. Right, so when I say Lambda, it stands for lateral movement and data access. And in any DFIR investigation, like one of the common goals is to identify how many systems were touched by a threat actor. Stakeholders commonly ask, like, what is the impact? What's the total number of impacted systems? So to answer that question, we enumerate lateral movement. And when I say lateral movement, it's basically when a threat actor compromises like an initial system in a network, they typically move to important systems like AD, file servers, and that movement like all together in the network is termed as lateral movement, as simple as that. All right, and whenever the threat actor moves to these certain or any systems, like they leave traces of their activity. So if they use Explorer, like we can use certain artifacts to parse Explorer and get the evidence that threat actor was there. And similarly, one of the main investigation goals is to identify what data could have been accessed or exfiltrated by a threat actor or threat actors. And to identify that, we parse data access artifacts. Again, by data access, I mean whenever a threat actor compromises a system, one of the major aim is to exfiltrate sensitive data. So basically, they traverse to certain systems via Explorer or may use remote management tools like WinSCP, Screen Connect, AnyDisk to exfiltrate that data. And again, like the activity that they conduct leaves traces behind. So we can parse that activity and prove the evidence of data access or exfiltration. Let's take a minute to see like how we can actually get that information. So we use forensic artifacts, and forensic artifacts are nothing but Windows features that are presented by Windows to enhance user experience. So for example, if you use RDP or remote desktop protocol to remote into certain systems, if you right click on that icon in the toolbar, you can see the commonly accessed or recently accessed systems. And that's there to enhance your experience so that you can quickly traverse between systems. And this feature is called as Jumplists. We can use Jumplists to parse the data present in the Jumplist and prove that a certain user at certain time connected to source B from source A. So that there is the evidence of lateral movement taken from Windows features, and in this case, Jumplists. So that's how we use Windows features to, and there are a lot of Windows features that can give you a lot of useful information in DFIR investigations. All right, let's take a look at what artifacts do we use in Lambda to identify lateral movement and data access. All right, beginning with Windows event logs. And just to note, this is a small representation of what we actually include in Lambda. We have a lot of artifacts. You don't need to take picture of this, it's all listed in the YAML file or the code that is on GitHub, which we will get to in ending slides. All right, to begin with, we include logins, logoffs, disconnects, connects from security as well as RDP event logs. We also include the PSexec service install. So that may not be a remote access feature. I mean, it remote interactive access, but it is a remote access and commonly missed when analyzing system event logs. So we do that for you. We also have Windows remoting or PowerShell remoting, again, a commonly abused Windows feature by threat actors to connect to remote systems, as well as SMB events or server message block access. It's like connecting to a network share from your system. So that will include information in these SMB event logs, which again can prove lateral movement.
Now there are obviously other artifacts that we use to identify lateral movement. Some of these also identify data access. It's a bit of a two-pronged sword. Some examples that we do include within LM specifically would be various registry keys as it relates to the usage of RDP, as well as mounting shares through SMB. We also use LNK and Shellbags, particularly just to notify you as an analyst whenever somebody is accessing another share remotely. Then we also do know that recently threat actors love clearing logs. At least I've seen it pop up a lot more in the past few weeks and few months with particular threat actor groups. But the UAL is one of my favorite artifacts, at least when it comes to lateral movement. We only consider 4 roles specifically, at least when it comes to LM. You are welcome to add more in the YAML file definition. It's not too difficult, but we only consider file, remote web, and FTP. File is going to be really the most useful, most voluminous for you. The reason I love it is when the event log is not available, you can generally get a pretty good idea of what's going on in the environment via the file, but it's only SMB access, so you do have to kind of consider that. Another source of lateral movement that we have seen in the past few years prop up, specifically using our MM tools, legitimate tools like TeamViewer, ScreenConnect, Splashtop, Altera, WinSCP, PuTTY, OpenSSH. So every single one of these tools usually leaves their own specific forensic artifacts that we can use to identify their use. Whether that is a file that is created by the actual application, whether it logs into the application log, whether it leaves some remnants within the registry hive. So we try and kind of get a more generalized idea of usage of these tools, just so that you as a practitioner, as an examiner, can follow up when you're doing your deeper dives if that's something that you so wish. For data access, specifically, some of these we've already mentioned, LNK files, Shellbags. We previously discussed Jumplists, which can be used to identify data access. We can also include MRUs, browser access for local file-based access. Also, mention of WinSCP in terms of we've seen high prevalence of it used for data exfil, as well as just local file access as well for transfer purposes. So these are all kind of forensic artifacts that we do consider as part of our initial data capture.
All right, so let's talk about why we decided to build these artifacts. Right, so before Lambda, I used to run my hunts one by one and analyze results one by one. So it was very efficient. It was not. I was not aware of all the different artifacts, and in like high tensed or fast-paced incident response, like certain times we miss commonly used artifacts. So that happened to me, happens to everyone. Again, not a good look. And lastly, I used to spend time cleaning outputs from multiple formats, multiple artifacts, one by one. That was me a couple of weeks ago before we invented Lambda. So again, these were the pain points we came across when performing DFIR investigations. So that is why we built Lambda. As discussed earlier, investigators may not be aware of all the different artifacts that there are, which there are a lot. Again, you do not need to spend time normalizing results from multiple artifacts. Like it's done for you in one single place. All you need to do is click buttons. And lastly, but not the least, we include or present results in a timeline format. So it's easier for you to just plug and play results from Lambda into your master timeline, or use this as a master timeline, because it includes like the most useful info and clears out or filters out the noise or extra information which you may not need to prove lateral movement or data access. All right, so that is me. Again, like I'm not that old, but yeah, my life was much easier after we started using Lambda. All right, let's take a peek under the hood, like how Lambda actually works. So like discussed before, we have like multiple artifacts into two configurable hunts. And when I say configurable, you can exclude or include artifacts as you will. So you do not need to use all the artifacts as we discussed. We present normalized results, meaning results from like LNKs, Jumplists are in a format that is not differentiated. So like, it's better if I show you how the results look like instead of explaining in further slides. We do have master sheet, which contain all results from all the artifacts, as well as individualized results. So in case if you wanted to focus on, let's say, LNK files only, you have the ability to do so. All right, and like mentioned before, we have it in a timeline format and under certain columns, like that's where the normalization comes in. Let's quickly take a look at columns that are available in LM output. We have the timestamp, obviously. The description column will mention if it's a remote access or access coming from PowerShell or SMB, security or like network access, etc. We do have source destination system as well as IP. So in certain artifacts, like you only get a system name, and in certain artifacts, you only get an IP. So wherever there exists an IP or system, like that information will be included. So we don't need to like go back, map what system belongs to which IP. And user account, obviously. The most important one is direction. We bifurcate or tag each entry as inbound or outbound. So you know like if an access is coming into the system or going out of the system. So again, very useful in determining like if it's coming out or coming in. For data access, again, starting with the event time, we have the user account who may have accessed that data that will be in the path column. We also include file size where applicable. So in case if there was an exfiltration event, you may want to calculate the total size of file or like file size of all the files that may have been accessed to like compare if this matches to the exfiltrated claims by threat actors. We have the time type column, which is of importance, which I will be explaining in further slides. And for both LM and DA, we have additional information. So if you need like extra info, like what is the type of access from security event log, whether it's a network access, remote access, interactive access, that is in there. So yeah, most useful info presented in normalized format.
Now let's talk a little bit about how it's built, at least more of the VQL perspective. Those of you that feel a bit haunted or find this a little daunting, VQL or Velociraptor query language is an SQL-like scripting quote-unquote language. Essentially describes what the binary itself does on either the server or an end client system. Really what's shown on screen here is, as Phalgun would say, the meat and potatoes of the artifact definition, not to be confused with a forensic artifact. Ironically, Velociraptor likes to use artifact definition to describe a particular action that you're taking on an end client. Here, we're showing you how we implemented the notebook section. So if you've used Velociraptor before, when you initially sent out a job for a data collection as part of a hunt, there's a tab on your task that outputs the results in a table. Typically, for every single source, as defined within that definition, you have an individual cell that has a table, and then the next cell a table for every single source. What we did is we essentially hijacked the first notebook cell to just add a very giant change statement of each individual source output as it relates within our larger artifact definition, which essentially allowed us to create that master sheet that we're talking about that contains all of the results from each individual source output. One thing to consider when working it, and this is really applicable for every single artifact definition within Velociraptor, the notebook usually always has a limit 50 statement per row. So if you are working with this, just make sure to find and replace your limit 50 statement to either a user account or a host name, an IP that you will want to go ahead and filter on, as otherwise you're definitely not working with the full data set. How this looks like in the actual notebook, this is the darkened theme version, so it's not the default look where it's just white background, but as you can see, the column names that Phalgun was previously discussing, and then if you wanted to kind of go to the individual output of a particular artifact, let's say terminal server registry keys, you just have to scroll down or press Control F and it'll find it for you, and it'll show you the output particularly just for that one artifact source. In the event that, for example, if it wasn't terminal server registry keys, if you wanted to just like look for your RDP events, just scroll down to the RDP section. Now, let's speak about how we can use this data set for visualizations, particularly like node edge graphs. I don't know about you folks, but I love a good visualization. We're going to be going through two separate examples, two separate tech stacks of, one a more simpler and click and go way, another which is going to be a lot more difficult to use, at least right away, but it does allow for higher customizations as you so wish. The first one is Grafana. So what you really want to do is go ahead and pipe your data over to Elastic. And then from there, set up a connector between Elk and Grafana to the desired index that you so want to visualize. The alternative format, which first we'll go on Grafana and then we'll double back, is going to be using Python or like Jupyter Notebook to visualize that data set. So Velociraptor does provide a Python module called PyVelociraptor that allows you to interact with the backend API of your Velociraptor server. You can issue any VQL query as you typically would from, let's say, the actual GUI interface. Then we can use the Python module within something like Jupyter as an example, along with some other Python dependencies like Bokeh to go ahead and visualize your ultimate node edge graph that you wish to take a look at. So let's see how it actually works. At least not from a demo perspective, but from a screenshot perspective. From the Grafana piece, your first task is going to go to your server events. We did create a custom Elastic Flows updater or uploader. That's a bit different than the one that's typically out of the box. The only reason is because the column names with Grafana are a little bit difficult. So it just kind of presets all the column names as you so wish or need it. So you can just import it into Grafana right away. It also edits the default naming convention of a Velociraptor index when it's being piped over to Elastic. So this is an example of what you would expect to see should your connector work correctly. I'll have the visualizations there at the very end from an index management perspective. Then you go ahead and launch up your Grafana. You go ahead and connect to Elastic. Give it a name, whatever you want that index that you want to visualize to be. Make sure your URL connector is set up and all ready to go. Then you specify the actual index in Elastic that you want to visualize. One few things to point out, just make sure that the time field is set to ID. That's part of that custom Elastic Flows updater that I have to make. You see the green check mark, it means you're all good. You can go ahead and click building a dashboard. To add the visualization, select the one that you created just previously a second ago, let's say RDP here. And from here, as long as you have node edge graph selected, you go ahead and start querying your data, similar as you would in Velociraptor's GUI, but now you can do it with like a node edge graph if you want to see lateral movement based off of a user account, a host name, or IP. Specify time ranges, but yeah, they have more visualizations, so you don't have to use the node edge graph. It's just available here for you, although albeit some of the column names are not necessarily going to work nicely with our custom flows updater as it's built for the node update, but you can use just any of the normal Elastic flows updaters for that. And here's just a more finer example of just using Grafana out of the box for that. For the Jupyter Notebook perspective, there's a few tasks that you have to take first in order for you to actually even be able to run commands against your server. First would be to create your Velociraptor configuration file, your API configuration file, which basically just contains like the URL and certificates that you need to connect to the backend API. You can either create a new user for this or specify an already existing user. You're specifying as an already existing user for your API config file. You just have to make sure that the user itself does have API client rights. Otherwise, the user won't be allowed to authenticate. From there, it's as simple as installing PyVelociraptor. Here's an example of a query command that you can use to run a VQL query against your server. This is usually like a really easy, simple test command that you can check to make sure that you have a connection. It will just give you some general information about your server. Now, from the Jupyter's perspective, what we'll be using is more so a functionality within PyVelociraptor, Yellow Pandas, that allows you to send a query and it returns it into a Pandas data frame, or rather into a data structure that you can import into a Pandas data frame. From there, really, the world is your oyster, depending on how you want to work with that data, massage the data. It's really up to you. From a visualization standpoint, you can take the Pandas data frame, you can pass it over to networks, and then pass it over to Bokeh to create a visualization such as this. This is using just test data, so it looks very uniform in terms of the connections. This is not necessarily a real life example of what a visualization graph across the network would look like, but the kind of key point of this using Jupyter is you can do whatever you want. At the end of the day, the data set's your own. If you want your edges to be color coded per user, if you want your nodes to be larger because of their in and out degrees, it's your wish. Use cases, why do we even want to do this? So for those that like visual things, this is a good alternative. In other perspective, if you are very fresh into a IR workflow and you don't have a whole lot to work with, you don't really have any indicators of compromise, the client doesn't really know what's going on, and you don't know where to start, but for whatever reason you decided to start from lateral movement, which can be a very big mess to usually start from. But you can do some quick analysis techniques like degree analysis of your nodes, right? Figure out your large in and out degrees. Basically, if a system is seeing a lot of like SMB lateral movement, that could be indicative of SMB scanning. And it's an example of where using degree analysis to pinpoint those high in-degree systems for you to take a closer look at would be useful. Multi-hop detection, so as we know, and Phalgun pointed out earlier, a threat actor moves from system A to system B, elevates credentials, then tries to reach another system to stage data, or run something like rclone to just exfiltrate it right away. Those are defined as like multi-hops. You go from one system to another. So there's some cool multi-hop detection, or rather algorithms that you can use to identify your multi-hops. You can constrain it to the initial session of where the user kind of starts, appears out of nowhere, thin air, and kind of track that user as it goes through systems for identifying those multi-hop sessions within an environment of your data set. A few things computationally expensive that are really probably not applicable in most cases, especially kind of high tense IR, because they just take too much time to set up. You can do like graph simplification via clique analysis. There are some really cool papers out there for like graph neural network implementations for anomaly detection. I would recommend some of you folks to read it because they could be very interesting. They have a really high success rate in detecting anomalies. Although again, very computationally expensive, and if you're coming into a hot IR and you have to follow threat actor steps, you're not going to take the time to set up all that infrastructure, import the data, go through it. It's going to take way too much time. But if you're, for example, working continuously with a client for years, you already have that data set, something to think of. And that's how visualization works.
All right, thanks, Kostya. So now that we know like how LM works, let's take a look at DA, or data access aspect of Lambda. All right, so like Kostya mentioned, DA is very similar to LM in VQL structure-wise. We do have normalized results similar to LM, but like columns will be different, as I discussed in previous slides. Again, we do have individual sheets if you wanted to focus on single artifact. Right, so now that you get results from DA, let's see how you can put it in a format that is easier for you, stakeholders, and anyone who will be like viewing the data access results to be better ingested. Right, so we have an Excel template on our GitHub. I will start with the overview tab. So like beginning with the coloring legion, we have certain predefined color codes to make everyone's lives easier. If, for example, a certain row or certain cell contain keywords like password or credentials, it will be automatically highlighted with respective colors. And that is like the conditional rules baked into the Excel template, which are easily configurable and again, just easy to differentiate between what could be a potentially sensitive access or sensitive data. Next, we have definitions for artifacts that we parse in case stakeholders or non-technical audience wants to know where the data is actually coming from. Like they have the ability to do so and understand like what is happening behind the scenes. And lastly, for the overview tab, we have certain review methodologies. If you wanted to like make sense of the data that will be coming from Velociraptor results, you can, like for example, follow tier 3. So this will lead you to something like if an employee is accessing data off the working hours. So let's say like there was access to sensitive files on a certain day at 1 a.m. That is an anomaly that the employee may not be expected to do that. So again, like that leads us to a potential incident. So that's how you can go with the data. Right, for the scenarios tab, we have listed certain scenarios that may or may not generate forensic artifacts. And these are specifically related to data access. So in case like a stakeholder does not understand like why sometimes forensic artifacts are generated and why sometimes they are not, this is a very good example and like tab to explain like how threat actor actions generate artifacts and how sometimes it doesn't. And lastly, the meat and potatoes of the Excel tab is the data report, where you can just copy results from DA artifact and paste it into the Excel template. And as discussed previously, the path column is configured with conditional rules. So again, keywords will be auto-highlighted with respective colors, and you can change them according to your will. Importantly, we have timestamp in UTC because that's the only timestamp in DFIR1. But we also put a local timestamp. It as is in Eastern Standard Time, but again, it's a very simple Excel formula. You can just click on this cell here and add or subtract how many hours you want. Easier to identify it in local time. Obviously, we have the host name, the user, and the path of the data access, the type. Generally, results from LNK, Jumplists, and browser access will be file access, but results from Shellbags and MRU registry keys will be folders. So one thing to keep in mind. And most importantly, the timestamp type column. So for artifacts like LNK, Jumplists, and browser access, this timestamp, like right here, will portray the actual time of access. But for certain artifacts like Shellbags and MRU, the timestamp won't be actual time of access. It will be the timestamp when that particular registry key was modified. So important point to keep in mind when you present to stakeholders so that you do not say something which is not true. Right, so that is how you can present the results from LM via visualizations and from DA via the Excel template.
So what did we talk about today? What are our key takeaways? So we talked about some forensic artifacts as it relates to lateral movement, data access, some more rather tier ones not tied to the Windows operating system, but as it relates to remote access tools. We talked about how we can take one single collection step in the beginning of our initial triage IR life cycle, and how we can take that data and output it into one master result file. They can use your master timeline, just cull data from it as you so wish, or add on to your master timeline from there in a more generally reasonable format, such that it is already all normalized, so you don't have to go ahead and normalize all your other data sets. You also can visualize that data, and however so you wish. We presented one example of visualizing into a node edge graph, and likewise you can use that data to analyze, report to your tech lead, report to any other additional stakeholders that you so have. Where can we kind of have you folks contribute? Velociraptor is an open source community, so there's always going to be additional Windows artifacts that are discovered, especially as Windows adds on new features. So if you folks have an idea of a Windows artifact that you want to go ahead and parse out or create, there is something called the Artifact Exchange on Velociraptor that you can go ahead and contribute over into. We also only talked about Windows, so there's obviously other operating systems out there, other platforms. So you can make kind of the same exact idea, but for a Linux environment, for a Mac OS environment. Lastly, we've presented a very rudimentary, and on the GitHub have a very rudimentary example of a visualization. But the whole idea is that everyone likes to visualize their own way. There are other procedures, there are other tools out there available. So if you folks have one that you like to use, or have one in mind that you would like to try out, go ahead and contribute back to the greater environment or community. For those of you who want to patch the phishing test, that QR code will take us over to our GitHub account, which is listed on screen as well if you don't want to scan the QR code. Yeah. We'll get back to this if you don't have a chance to. A few shout outs, some folks that helped us inspire the way that we wrote the actual VQL artifact shown on screen. Some of these folks are pretty well known in the Velociraptor community. Some of these folks have made some pretty cool artifact definitions available on the Artifact Exchange as well. So something to give a shout out to.
All right, here are the meme sources. Hide the pin hat is my favorite. That's my representation when I work. Our testing included the second to latest version of Velociraptor. The latest was updated a week before. And then for Windows machines, we use Windows 10, Windows 11. Again, if you found this a little bit helpful, we have a whole lot of thought leadership coming out. We continuously talk at different conferences. We will be presenting this Lambda as well as like another tool that I have at Sector, Black Hat Canada, in a couple of days. So if you are there, catch us up. You don't have to sit through our presentation. Yeah, say hi. Again, you can follow us on LinkedIn or Twitter, whatever. We have presence in certain countries like Level Blue. Again, like Kostya mentioned, is a world's largest MSSP, pure play MSSP. Alrighty, thank you so much for joining us. And again, feel free to reach us out on LinkedIn. We are easy to find. And thank you so much. We are open to questions.